When sizing a generator set for a fire pump, you must consider the locked rotor rating of the fire pump motor. The locked rotor rating is the amount of current the motor draws upon initial startup, which is significantly higher than its running current. The generator set must be capable of supplying this surge current to ensure the fire pump starts reliably. If you don't account for this, the generator set may not be able to handle the starting current, leading to voltage dips or even failure to start the pump. You should size the generator based on the fire pump motor's locked rotor amps, or LRA, as this is a critical factor in ensuring the system's reliability. In addition to sizing the generator set based on the locked rotor amps, it is also essential to provide a normal power supply from the utility with a transfer switch. This is required regardless of whether you choose a diesel or a natural gas generator set for backup power. The fire pump should ideally operate on normal utility power whenever available for efficiency and cost effectiveness. A transfer switch is utilized to automatically switch the fire pump's power source from the utility to the generator set in the event of a power outage. This ensures continuous operation of the fire pump during emergencies, which is critical for fire suppression. The transfer switch monitors the utility power, and upon detecting a power loss or significant voltage drop, it automatically initiates a transfer to the backup generator set. Once the utility power is restored, the transfer switch will automatically switch the fire pump back to the normal power source. The fire pump motor's locked rotor amps is the maximum current the motor will draw when it initially starts. Generator sizing based on the locked rotor amps ensures that the generator can handle the high inrush current without experiencing a significant voltage drop or stalling. This is vital for ensuring that the fire pump starts quickly and reliably during an emergency. Providing normal power from the utility through a transfer switch allows the fire pump to operate efficiently and reliably under normal, non-emergency conditions. The transfer switch ensures that the pump transitions seamlessly to backup power in the event of a utility power outage. This setup maximizes efficiency by using utility power when available and providing a reliable backup source when needed. When determining the appropriate generator set size, you must consult the fire pump motor's nameplate for the locked rotor amps value. Use this value to calculate the required generator set capacity, considering any additional loads that the generator set may need to support. Ensure that the generator set specifications meet or exceed the fire pump motor's locked rotor amps requirements. This is often found in the motor specification sheet. When installing a transfer switch, be sure to comply with all applicable electrical codes and standards. The transfer switch must be properly rated for the fire pump's voltage and current requirements. The transfer switch must also be installed in a location that is easily accessible for maintenance and testing. There are two main types of transfer switches, automatic and manual. For fire pump applications, an automatic transfer switch is typically required to ensure seamless switching between the utility and backup power sources without manual intervention. Manual transfer switches require someone to physically switch the power source, which may not be feasible during an emergency. Automatic transfer switches provide a faster, more reliable transfer, ensuring continuous operation of the fire pump. When choosing a generator set, consider factors such as fuel type, noise level, and emissions. Natural gas generator sets are often quieter and produce fewer emissions than diesel generator sets, but they may require a natural gas supply connection. Diesel generator sets are generally more fuel efficient and can operate for longer periods on a single tank of fuel. Consider the available space and ventilation requirements when selecting a generator set location. The generator set must be installed in a well-ventilated area to prevent overheating and ensure proper combustion. The location must also be accessible for maintenance and refueling. Regular maintenance is essential for ensuring the reliability of both the generator set and the transfer switch. Follow the manufacturer's recommended maintenance schedule, which typically includes inspecting and cleaning the equipment, changing filters and fluids, and testing the system under load. Keep detailed records of all maintenance activities to track the system's performance and identify any potential issues. Testing the fire pump system under load is crucial for verifying its performance and ensuring that it can meet the demands of a fire emergency. Perform regular load tests, simulating a fire event to confirm that the generator set can provide the required power and that the transfer switch operates correctly. During a load test, monitor the voltage and current levels to ensure that they remain within acceptable limits. In addition to the locked rotor amps, also consider the fire pump motor's full load amps, or FLA, when sizing the generator set. The full load amps is the current the motor draws when operating at its rated horsepower. The generator set must be able to support the full load amps of the fire pump motor, as well as any other loads connected to the generator set. Calculate the total load on the generator set, including the fire pump motor's full load amps, lighting, and any other equipment that will be powered by the generator set. Use this total load value to select a generator set with sufficient capacity. When sizing the conductors for the generator set and the transfer switch, follow the National Electrical Code, or NEC requirements. The conductors must be sized to carry the maximum current that the generator set and the transfer switch are rated for. Consider the ambient temperature and the conductor's insulation type when determining the appropriate conductor size. Use the NEC ampacity tables to select conductors that are suitable for the specific application. Properly grounding the generator set, the transfer switch, and the fire pump is essential for safety and to prevent electrical shock hazards. Follow the NEC grounding requirements for grounding the equipment. Use a grounding electrode system that is appropriate for the specific site conditions. Ensure that all grounding connections are secure and properly tightened. Install overcurrent protection devices, such as circuit breakers or fuses, to protect the generator set, the transfer switch, and the fire pump from overloads and short circuits. The overcurrent protection devices must be sized to protect the equipment and the conductors. Follow the NEC requirements for selecting the appropriate overcurrent protection devices. Consider the voltage drop in the conductors when sizing the generator set and the conductors. Voltage drop can reduce the performance of the fire pump motor and other equipment. Minimize voltage drop by using conductors that are large enough to carry the current without excessive voltage loss. Calculate the voltage drop in the conductors using the NEC voltage drop formulas. Select conductors that limit the voltage drop to an acceptable level. Provide adequate ventilation for the generator set to prevent overheating. The generator set produces heat during operation, and if the heat is not properly dissipated, the generator set can overheat and fail. Ensure that the generator set is installed in a well-ventilated area, and provide adequate airflow around the generator set. Consider using forced ventilation, such as fans, to improve the airflow around the generator set. Install a fuel storage tank that is sized to provide an adequate supply of fuel for the generator set. The fuel storage tank must be sized to meet the requirements of the local fire codes and regulations. Consider the fuel consumption rate of the generator set when sizing the fuel storage tank. Provide a fuel level monitoring system to track the amount of fuel in the tank. The fuel storage tank must be protected from damage and vandalism. Consider installing a fuel containment system to prevent fuel spills. Provide a remote annunciator panel to monitor the status of the generator set and the transfer switch. The remote annunciator panel should provide visual and audible alarms to alert personnel to any problems with the system. The remote annunciator panel should be located in a readily accessible location. Provide training for personnel on the operation and maintenance of the generator set, the transfer switch, and the fire pump system. The training should cover the proper procedures for starting, stopping, and troubleshooting the equipment. Training should also cover the safety precautions that must be followed when working with the equipment. Keep a detailed record of all inspections, tests, and maintenance activities. The record should include the date of the activity, the name of the person who performed the activity, and a description of the activity. The record should be kept in a readily accessible location. In addition to the NEC, also comply with all applicable local codes and regulations. The local codes and regulations may have additional requirements for the installation, operation, and maintenance of the generator set, the transfer switch, and the fire pump system. Contact the local authorities to determine the applicable codes and regulations. Before starting any work, obtain all necessary permits. The permits may be required for the installation of the generator set, the transfer switch, and the fire pump system. Contact the local authorities to determine the permit requirements. Work with a qualified electrical contractor to install the generator set, the transfer switch, and the fire pump system. A qualified electrical contractor will have the knowledge and experience to install the equipment safely and correctly. The electrical contractor should be licensed and insured. Consider the environmental impact of the generator set. Generator sets can produce emissions that can contribute to air pollution. Consider using a generator set that meets the latest emissions standards. Consider using alternative fuels, such as biodiesel, to reduce emissions. Properly dispose of waste materials, such as used oil and filters. Recycle materials whenever possible. Implement a comprehensive safety program to protect personnel from hazards. The safety program should include training, procedures, and equipment. The safety program should be reviewed and updated regularly. Perform a hazard analysis to identify potential hazards. Implement controls to mitigate the hazards. Provide personal protective equipment, or PPE, to personnel. Regularly inspect the equipment to identify any problems. Repair any problems promptly. Follow all safety precautions when working with electricity. Use insulated tools. Wear appropriate PPE. To energize equipment before working on it. Test equipment before energizing it. Be aware of the potential for arc flash. Maintain a safe working environment. Keep the area clean and organized. Provide adequate lighting. Ensure that there is adequate ventilation. Provide fire protection equipment. Have a fire evacuation plan. In summary, ensure the generator set is sized appropriately, especially for the fire pump motor's locked rotor amps. Provide normal power through a transfer switch. Comply with all applicable codes and regulations. Work with a qualified electrical contractor. Implement a comprehensive safety program. Through careful planning, design, and installation, a reliable and safe fire pump system can be ensured.